Welcome everybody for the ACM India monthly webinar series. As usual, we'll start with a quick introduction to the topic and the speakers, and then hand over the floor to the speakers. And the attendees, a request for you, if you have any queries, there is a chat window available for you to type your queries. And as the session progresses, either me or Venki, we will read out the questions at regular intervals for the speakers to answer. So with that, let me start introducing the topic and the speakers. Today's session title is Observing LLM Agents and Their Tool Calls. And this session focuses on two main themes: a taxonomy for monitoring both agent reasoning and tool invocation behavior, highlighting the distinct challenges in each. And the second topic is framework that captures artifacts generated across the agent lifecycle to enable targeted debugging of the tools and agents executing multi-step tasks. We'll see more details what exactly each of these themes means in the next 1 hour. And we have today two distinguished speakers. I would like to introduce Renuka, who is a senior technical staff member and research manager at IBM Research India. Her research focuses on building, evaluating, and monitoring enterprise tools for AI agents. In the recent past, she has worked on innovations in business process monitoring and mining. And the second speaker for our today's session is Asaf, who is a senior manager for AI agents at IBM Research. He is passionate about innovation that matters, driving business transformation through emerging technologies. In recent years, his work is focused on supporting AI agent builders with technologies to build, debug, test, and optimize AI agents. That is mouthful, but without keeping you on much more weight, I would like to give the floor to the speakers.
Okay, hello, thank you, and good morning, and thank you for joining us over the weekend. I really appreciate it, and thank you for the opportunity to share with you some of the work we are doing at IBM Research. Both Renuka and I are part of a global team working on AI agents, middleware component, inventing what's next for AI agent in the enterprise. And we'll give you today a glimpse of some of the things that are happening in this global team. And I'm sure many of you have some experience in building agents. And as you build your agent on whatever agentic framework of your choice, whether it's LangGraph or LangChain or CrewAI or whatever you have chosen to use, you've probably seen this. It's really, really hard to debug your agent, to improve it. And what we are doing in Agent Ops is we're providing the technology, or our goal is to provide you with technologies to help you debug, improve, and maintain your agentic system throughout its lifecycle through actionable insights, recommendations, and automatic optimizations. So in order to make that, we've created three components. One is an observability SDK that is based on open standards, specifically open telemetry for data collection. We'll deep dive on that in a minute. Then an analytics platform that enable pluggable and composite analytics dashboard and abstractions and API for you, for IBM, and for others to develop their own analytics, insights, and recommendation. And of course, a visualization layer on top of it that will allow the agent builders and data maintainers to understand how the agent operates and how it influences the entire system. When we're thinking about agents, there are multiple personas that are involved in the agentic lifecycle. These could be pro-code developers that are using a framework like, as I said, CrewAI, LangGraph, LangChain, really writing agent code. There are low-code developers that are using higher-level framework to configure existing agents. Once the agent is built, it needs to be tested. And once it's deployed, it needs to be maintained by a site reliability engineer. And we also need to make sure that it's operated according to the guidelines and in the enterprise. You can see here the different products that we have in IBM to support all these personas, and what they are all sharing the same technology to maintain and the agentic systems. And if we do it correctly, we get, transparency of the agent decision making. We understand how the agent works. We then have the ability to identify where it fails, what issues do we have, diagnose and resolve these issues. And of course, the goal is to be able to resolve some of these issues through real-time learning and optimization. So what we'll do today is we'll talk about the main components of such an agentic observability system, and some of the consideration that we had in the designing of such system. But before we jump in, I'd like to spend a few minutes about the taxonomy of agent automation pipeline, because automating and observing an agent is a full pipeline, starting from observing what an agent is doing. And this could be around monitoring the agent memory, the feedback from the human, to trace the agentic workflow, to identify different actions the agent is doing with other parts of your enterprise system or your system. Then we can take all this observation data and start to calculate metrics like usage, quality, and latency. This is around the agent quality, to try to evaluate how the agent work over time. So things like issues and coverage, and look at different type of metrics depending on the different phases of the lifecycle and the agent. We can also take these observability data in order to detect different issues. This could be around task that has incorrect or incomplete output. It could be around tool calling, and Renuka will talk about that specifically in a few minutes. Issues around feedback that is provided from the user. The user itself can provide, a feedback on the agent, etc. We can then take these issues and try to identify through analytics the root cause analysis of these issues, whether it's in the agent prompt, or maybe it's in the how the agent is structured, or the sub-agents are built. Next is to optimize, to recommend how to resolve this issue once we have seen the root cause. And of course, the end phase is to try and actuate and operate the recommendation automatically. And by that, we got a self-optimizing agentic system. So I want to show this in a real example that we developed with some of our colleagues in IBM that are building a site reliability engineer agent to support IBM's technical team that are responding to our customers' tickets. So I'll just use this as an example. So in the observation phase, we are tracing the agent, tool calls, input and output on the agents. Then we could detect an issue. For example, an issue could be a problem in the tool invocation, like an incomplete output. This is interesting, but it's more interesting when there is an increase in this type of issues. It may happen once, and the agent may be able to recover from an incomplete output, or maybe the output is really incomplete. But if we see an increase in these type of issues, we know that we have a real problem. And this is an example of compound analytics, where the issue detection analytics is output is used as a basis for another analytics, which is a change point detection. So we've just identified an increase in tool invocation incomplete output problem. Root cause analysis might find out that this is because we've changed the prompt a couple of days ago and the prompt became inaccurate. We have this technology already in IBM. This is called prompt optimization technology, one of the analytics that we have. Then we can recommend how to improve this, how to change the prompt, update the prompt in the agent, and continuously monitor the agent. So this is an example of how we leverage this type of capabilities during operation, but you can imagine how this could be used for debugging, and actually you don't need to imagine because we see it in a minute. Maybe now it's a good time to go to a demo, and then we'll continue to talk about the technology. Yeah. So this is the hard part of the presentation, to successfully move between PowerPoint and Safari. Okay, just a second. Okay, so this is Agent Ops, and we are now looking at a trace of an agent that is called NL2 formula. It is built by some colleagues of us in Yorktown Research Lab. And the goal of this agent is to take a natural language expression and create a formula, think like an Excel formula, but in a tool that is called Maximo. It's an IBM enterprise application for asset management, creating these formulas or taking a user query and creating a formula to calculate the data is quite complex. Not a lot of our customers have the skills to do it, especially not the users, the end users of the asset management platform, which are usually asset technicians working in the field, and this agent aims to do it automatically. So the first view we are seeing is called the span views, the span view, and actually this is the standard view that you have in most of the tracing application. You can see it's really hard from this view to understand what the agent is doing. And this is because this view is too detailed. It shows every span or every small activity the agent is doing, and it's not presented in abstractions that are relevant to agent builders. So we've created the task view. The task view actually shows the same data in a higher level abstraction, and we can immediately see okay, now it's better. We can immediately see the task, okay, the several subtasks that exist in the task, the number of tool calls, the duration it's taken, and few other pieces of information. So let's try to understand together what is this task is doing. So we'll go to the first subtask, which is let's see what it is. So let's open the subtask, and we can see it here that there is a query from the user: write an object formula for asset object to calculate the asset's third year of life. Okay, let's so we know this is the request from the user. There is some information about the relevant schema, and the thought of the agent is omitted into this something that is called a scratchpad in this agent. Next phase is it's called fine syntax. So I guess I actually wanted to show the output every time. So the output will be a list of relevant functions, an operator in Maximo that could be used to write this formula. The generate expression actually suggest an expression. So the LLM suggested through a tool called an expression to solve this user task or user request. Then the parsing, I'll just look every time at the output. So yeah, the output of the agent is checking that the formula is correct from syntactic level. It can be parsed. Then it's going through semantic review. At the end, there is an explanation to the user and how the formula was calculated. So you can see the several phases of this agent. Again, I didn't write this agent. I've actually first time looked at it last night when I prepared to this demo. But you can see also that in this agent, the way they've selected to build it, that every time they add to the scratchpad all the thinking process of the agent. So the context for the input to the LLM is continuously increasing. So they have a risk in this agent to get into too long context because how it is built. I want to show you another agent, another trace from the same type of agent. So the trace I will show you is the one that is LM93. Yeah, okay. Okay, and in this, we can see that this is a longer trace. We did a parse. We found out that there is a syntactic error in the request, probably because, sorry. We can see that there is another request. The request is to write an object formula to find the year-to-date cost or replacement cost. And we can see that the parsing phase to make sure that the suggested formula was this one. Did not pass parsing. It did not pass parsing because the minimum function does not exist in Maximo. So we call the generate expression again, and once we call it again, we got a different formula, and this different formula is correct syntactically and semantically, and the agent was done successfully. What we are also seeing is that a cycle was detected. So this is one example of an issue. It's a warning because one cycle might not mean anything, but imagine that the agent would have done that, I don't know, 10 times. That might be a problem that we want to avoid. Another view that we have is the workflow view, and the workflow view shows how the agent works. So if we, in case that we don't have cycles and everything goes well, we would expect a vertical kind of a spaghetti line. This is not the case here. We see that after generating the expression, we go to the parse task that checks that the agent is syntactically correct. If there is an error, this goes back to the generate expression, like we've seen. But if the parse task is successful, it goes to semantic validation and to explain the task. You can think about this view as kind of a process mining view for the agentic flow. In this case, we are seeing just one agent, but we have the option to select multiple agents, create an agent group, and look at multiple spans together in this view. For the sake of time, I will not do it today. I want to take you to another agent. This is another agent called Kuga, Computer Using Generalist Agent. This is an agent that is capable. This is a generalist agent that can work across web and APIs type of tools. And again, you can see that the default span view has too much information. It's hard to understand. But on the other hand, on the task view, you can actually understand what the agent is doing. It's doing a task analysis, and then decomposition, plan, perform an action. An action would be, in this case, a click on the UI. And we can also see that in the workflow view, this agent actually worked more or less as planned. But let's say we go into the action agent. The action agent needs to do the click on the UI, in this case, of the web agent. We can see if, for example, if it needs to do a couple of clicks, there is a loop here, and that makes sense. Two more things I wanted to use this view to show you is one is the trajectory view. And the trajectory view gives the agent builder the ability to see the thought process of the agent. So in this case, the intent from the user was to search if there is a flight from Tel Aviv to Madrid. We can see the JSON, the internal JSON text that was transferred internally from one sub-agent to the other. We can see it either in a JSON view or in a tree view. We can see here the thinking process of the agent. So the agents find out that this is the decomposition find out that intent searching for a flight. It's decided that just one. This is just one task. It does not need to be composed, and this should be done through a UI. One of the ability, and I'll talk about that in a minute, of our agentic observability platform, or specifically the SDK, is to do automatic instrumentation or manual instrumentation. Manual instrumentation, in this case, the agent developer has manually instrumented the thinking process of the agent, but because it's a web agent, it's also manually instrumented what the agent is viewing on the web. So you can see the welcome page, which is a Microsoft Bing search, and close this. And as the agent move forward, you can see that the planner agent says we are currently on our Bing search agent homepage, and the first plan is to enter search query in the search box. It goes to the action agent that decided that in the search field it needs to write this text. And I want to show you how this is the result. Okay, after the action agent write this text and press the search button. He actually had to do it twice. He got to this page, and this agent continues. The Q&A agent role is to retrieve what he sees on the screen. So he said that this is a result page, and it contains multiple links, etc. And the planner agent actually thinks, okay, so what is the next thing I should do? The next thing is to answer, in this case, that there is an AL flight from September 1st to Tel Aviv. I'm not sure the agent answered correctly in this case, because we wanted to get the details of the flight if I remember the task correctly, but that was the final answer. One more thing so we've seen all the views. One more view that we have is an eval view, where we use LLM as a judge to evaluate every prompt in every node in every prompt that is called for every sub-agent. The eval view actually show you the specific prompt, give evaluation, and a ranking from 1 to 10, where 10 is the best, and you can see that overall the prompts are, and the agent has been working more or less correctly. So before I go deeper and talk a little bit about how this type of system works and how it can be extended with more views and more analytics, I'll stop for questions.
Thanks, Asaf, for the demo. There's one question. I'll just paraphrase and let me know if you can respond to this. So when we query the LLMs, every time we ask the same query, the LLM may respond differently, right? You may get different answers. So how does the agent address this kind of differences in response? I think that's the question. I'm just paraphrasing it.
Okay. So again, this tool is not an agent building tool. So the agent developers has to know how the agent work and how to manage the different LLM calls. This is an observability and analytics tool that shows you how the fact that the LLM answer differently every time, and because there's a lot of inconsistency and variability in how the LLM answers and how the agent behaves, it gives you a view about this behavior, the thinking process of the agent, issues that you have in the agent, so you could better debug it and maintain it over time.
Can you share some details of the tool? Are these tools available for everyone to use? And how do these tools compare to, say, LangFuse or Langsmith?
Excellent question, which will lead me to back to the deck, and I'll answer it through the deck. So I actually have this capability should be available in open source very soon. So for everyone to use, it's already embedded in some of the IBM products that I mentioned, but it should be available as open source. Regarding differentiation to the other framework, I'll touch about that in few minutes. So please park the question, I'll reach out to you.
There are no further questions, Asaf. Please continue. Thanks.
Okay. Cool. So, okay, so a few words about how this works. So we said, I started by saying that we have, we built that in 3 layers or 3 components. The first one is an observability SDK that is based on the open telemetry standard, Otter. And the goal of the observability SDK, by the way, it's already an open source package that enable automatic and manual instrumentation of your agent. What do we mean by automatic? Just by adding these 2 lines of code here to your agent, the SDK will start and observe all the basic data of your agent. Out of the box, it supports LangGraph and QAI and LangChain, MCP, and many other format. There is manual instrumentation, and we've seen an example of manual instrumentation that you, as an agent developer, can omit additional data. For example, in Kuga, we've seen the agent developer share information of the views that the web pages that the agent is looking at. When we're thinking about observability of agentic data, there are several research challenges that we are looking at. And on the links here, you can see some of the papers that address those. First is open telemetry data. The basic open telemetry is like a pipeline. It has semantics for spans, traces, and metrics. And it's completely ignoring the semantics and the taxonomies of agents, such as tasks, which are higher-level abstraction that the agent is working with, agents, issues, etc. And we are proposing an extension of OTel based on LLM metry, which is another extension of OTel, that include and that bring agentic terms as higher first-class citizen into the OTel standard. Second, we need to remember that the agent is, especially an agent in an enterprise system, is just one component of a bigger system. So we need to be able to propagate context from the agent to the rest of the system and back. And this is especially important in day 2 observability. When we want, for example, to understand how the agent affects other services that we have in our system, for example, affect the database, or affect a web service that is using, or API that is using of another system. Maybe it causes a load. Maybe the vice versa, an issue in the system caused the agent to fail, and we need to understand that. And last, everything around volume management, how to keep the agent data for how long, how to manage it, security, privacy. Agent data include information from LLM and traces that might include PII. So everything here is need to manage. The second layer is extensible analytic platform. An analytic platform, when we think about it in the enterprise, I'll go bottom up. It starts from the observability SDK. Then we have an infrastructure layer that enable you to register your analytics, an analytics agent, and a database that keep all the traces and the results of the analytics. Now we understand that in enterprise setting, this database could be on or hosted, could be on-prem, and should be whatever the enterprise user actually want. So that we build it in an open way that you can plug in any data storage here. And you can replace it and use the data stores of your choice. Then we have the analytic extension. And some of them are built in, like the ability, the higher level tasks that we have that could be used as input to other analytics. And last is the UI layer. And we understand that different customers, different products will want different views and different look and feel for the same type of analytics. One of the unique differences that we have in Agent Ops is that the analytics platform is pluggable, meaning you can add your own analytics. In IBM, we are working with multiple research teams, including Renuka's team, to add more analytics. But this is one major differentiator to the open source and commercial platform out there, which are not extendable. The best you can do is some filtering and modification of the views. We actually started with the demo, so we've seen all the views and capabilities that we have up to date. So just to summarize, couple of differentiators that we have in IBM compared to the vendors out there. I think the question was around Langfuse and Langsmith and Traceloop and Langtrace and dozens of vendors out there. First, we are the only one that have higher level abstraction to treat agent tasks tools as first-class citizens as part of our observability SDK. This makes the life of the agent developers, especially if they want to do manual instrumentation, much easier, because now it's not just pens and traces, but higher level abstraction. Second, we are the only one, we have an extendable pluggable analytic platform, unlike other vendors that offer only dashboard level customization. And the fact that we are enabling others to add their own analytics and extend the platform, extend the analytics. It means that we are also enabling compound analytics. So for example, and this is a true story, I think Renuka, you've contributed the tool issues detection that I've showed initially in the example. Researchers in my team in Israel have created the change point detection. Combined together, we have change point detection on tool issues. So we have a standardized semantics to do compound analytics, and this is an X factor. We have unique views around task abstraction that does not exist anywhere. Multi-trace workflow view and trajectory exploration that are much more advanced than in the competition. And few words about IBM. If you look at the vendors out there, they are all focused on day one, on the developer. IBM is the only company that today that offers a uniquely integrated agentic and observability stack. We have Watson Orchestrate, which is a low-code agentic development framework, and Red Hat, which is low-code pro-code agentic development framework that focus on the developer and provide, based on agent ops, provide tools to debug your agent. And we have Instana, which is our observability system observability platform that extend into the agentic world and enable you to monitor the day-to operation of your agent and your entire system together. And there is only one vendor today that can do both, looking at the development time and day two. And of course, we know these are all connected. So thank you very much. I'll stop here, and if there are any questions, I'll be happy to answer. If
there are a couple of questions I'll just read out for you. Well, of course, you already answered this partly. You talked about the tool becoming open source, but in the meantime, there's a question if there are any modules that can be made available for practicing agent observability.
I think you can practice. There is an IBM product called Watson Orchestrate, where this framework is available. There is I think a 30-day free license for it, and through the Watson Orchestrate ADK, you get all the capabilities of agent ops. ADK is the application development kit for
Right.
what.
There's one more question. Again, I think you've already answered it. Maybe you need to clarify this one more time. If the LLMs generate different answers for the same query, how do we support, how does agentic AI generally work, especially in the area of cybersecurity?
Okay, so actually, I'm not a cybersecurity expert, but we actually have a cybersecurity team that are adding more and more analytics into the framework security type of analytics.
Okay, thanks, Asaf.
Thank you.
There are no further
Thank you
questions.
for the opportunity to. Thank you for hosting me, Renuka.
Renuka, over to you.
Sure. Okay. Thanks, Asaf, and thanks, everyone. So here, as Asaf took you through a overview of what observability in the agentic framework is, I will dig down into one step, focusing on tool calls, right? And specifically here, tools means external functions that the LLM uses to get more context. So when you say, what's the weather today, you would have typically seen that example where there's a tool which will give you the weather, and the LLM can use that to give you that information. So I'll just motivate on why we need this kind of tool calling. And this is very real requirements. So this is one example of within IBM, we have some application called Ask HR. And if you see most of these enterprise systems, they're very complex for an end user to use them. So what we've done is given an kind of natural language interface, which the user can interact, and behind the scenes, an agentic framework sits, right? So here's one example where the user is saying, what are my absence balances, right? What are my leave balances? And so you will see that there's an agent getting picked up, which is a leave manager agent. It says, okay, for this user, first thing I need to do is get what the user ID is.
Renuka, I'm sorry, are you sharing?
Yes,
Yeah,
I'm
you
sharing.
can see it.
Okay, let me share again.
You were able to see it, Renuka, so
Yeah, we were able
so
to.
maybe you.
Okay, just me. I'm sorry.
Okay, so yeah. Okay, then I'm going ahead. So if you just saw, it's figured out the agents, it identified the right tool, and then after getting, and here it might need one or more tools. Like I said, first needs to get the user ID, then gets for that user ID, what are the leads, and then gives you that information. So here's where you would actually be interacting with real enterprise APIs at the back end and be answering user questions. And we've seen that this is very useful. There are some stats here which says a lot of hours were saved where users were able to interact directly, ask their questions, and get information, right? So this is just a broad view of where tool calling is required, right? And next I'll go to how this tool calling works. So this will give you a good idea about where there could be types of errors, right, which we need to observe and debug them, right? So typically when you have this in an agentic scenario where a user asks a question and you need to get this information by calling a tool, there are three inputs that a language model would take: the user query as such, then there would be some system prompt which would guide the model what to do. And another very important input would be these definitions of all the tools that are available to the LLM for it to make a call. So here's one very simple example. It would have the details of an add function with this description, what parameters it takes, and so on. So all these form the input that an LLM could take. And when the user asks a query, it would actually formulate that particular structured tool call. So as you see, LLM cannot actually make a tool call, right? All it can do is generate text. So it generates this very structured input about what function to call, what are the arguments, what are the values, and so on. And some framework like LangChain and would take this information and actually make the tool call. So that is where it will call the tool runtime. It will get that information, give it back to the LLM, and the LLM would give the response to the user. So to highlight the key things, you need to have these tool definitions. The LLM needs to know how to formulate the output. and get the formulate the input as well as get the output and show it to the user. So this is the overall flow. Now, in this context, this is how the interaction would look when a user is using it. So here is a very simple example of I have GitHub. I'm asking the user things like get me all the issues. The LLM formulates it in this input. It says, okay, I know I need to call list issues. This is from the user utterance. I know I need to figure out this is the owner. This is the repository name, and then calls the tool. When the tool gives a huge JSON response, the LLM would make sure it gives the response, formats it, and gives the end answer to the user, right? And what normal observability tools would do is look at some of the metrics related to tool call, which would be things like how many actually agentic runs involve tool calls, some of these metrics, right? What was the latency of the tool? So here you would know there is this particular tool which is widely used. There's one particular tool whose latency is very high, and there are errors related to the tools. So these are the broad metrics that tools like Langsmith and all provide, right? But what we, along with Asaf's team are looking at is saying, this is not enough. The user needs some more insights into where tool calls are happening, how are they failing, what are the issues, and so on. Okay? That is where we are going one step deeper and identifying various types of issues and then categorizing them and reporting them. So I'm just listing down few errors that could occur with tool calls. This is certainly not the exhaustive list, but I want to give a sense of what could be the typical problems with tool calling, right? And some of these would be model related. So maybe the model is not able to select the right tool, or it's not able to formulate that structured input that I showed. It's not able to form that correctly. Or it cannot process the output of the tool. The tool is running, everything is fine, but there's some model limitations, it can't process the output. So that's one set of problems. There can be many more, I'm just listing the top few. Some of these would be tool-related problems. Tool is not giving enough information for the model to pick it up, right? There's some lack of information in the tool description, what the tool is doing, the tool's intent, lack of information about what should be the input for the tool for the LLM to call it properly, or lack of information about the output. And some of these could be both of them interacting together. So we've seen scenarios where maybe the tool makes some incorrect call, the model the model makes an incorrect call, the tool is unable to give enough information, so the model doesn't know and keeps trying again and again. So this is what we call repeated tool calling, and what was referred to by Asaf also saying cycles. So it keeps on going into cycles. You want to detect all these errors and highlight it to the user. Okay? So I'll go into details of some of this, so it will give you some insights about where things could go wrong, how things could go wrong, and what we are doing to observe these issues, right? So I'll take few tools which are fairly simpler, or you would have used them, things like GitHub tool. Here is an example of a Jira tool, right? Jira is another software development lifecycle management tool. So here you have the model might have many tools in its that it has information about. I'm highlighting just these two tools. So this is how a tool definition is given to the model. It will have details about what's its name, what is its description, what is its planning to do, some of the details about what are the parameters as input and so on. So here there are two tools, which is related to Jira, which is get my issues and get the projects. So both of these get the details of issues and projects in Jira. And the user can give this query saying retrieve 50 issues for a new project called Project Alpha. And then it's just that the model issue that it's unable to detect whether it should call this tool or this tool. And sometimes it can be as simple as because of the keyword. So because the user said new project, the model is now confused whether it should look at projects or issues. You just you give another utterance, it might be perfectly fine figuring out the right function. So it's better you identify these are the kind of issues, these are the utterances where a particular model is struggling to choose one tool versus the other. So this is something you want to track. The other issue could be things like formulating the right input argument. Here again, I'm giving the same example of a Jira tool, which needs to get issues from its repository. And the user has asked things like, get me the list of issues for this project, for this issue, and limit the number of results to 25. Okay. The tool definition is fine. The tool says limit should be of type integer. But there is some inherent problem in the model that it passes it as a string. So we would call this as a type mismatch issue. So then when the tool gets executed, then depending on the error handling of the tool, it might say, okay, I'm getting an incorrect type and it might fail, right? Sometimes the model might pass something like, it was actually the project name was Alpha, Project Alpha, but in this case, it might just pass Alpha. Okay? So there are a lot of these issues that you would want to detect and categorize them. Was it a problem with the input parameter? Was it the problem with the input value? There could be problems where the model hallucinates new arguments. It's not there, but it hallucinates, or it might give a different name. Instead of project name, it might just say project. Okay? There can be various issues with the model in formulating this input. And another model issue could be that it cannot process the output from the tool. Yeah, and here I'm just giving these two examples. Here is a tool which we saw, GitHub. It lists issues from, retrieves the issues from particular repository and shows it to the user. So if I say, get me all the closed issues in Microsoft VS Code, obviously there are a ton of closed issues in that particular repository. The model calls that particular tool. Now, it is inherently in the tool implementation that it would be doing some pagination and so on. It gives enough information and the model is able to show this details, process the output. Suppose I say, give me 50 issues. Okay. Now, the tool gives all the 50 issues. It's a problem with the model. The model cannot handle such a large context. It would give these errors. Now, the idea for us during observability is to identify all these kinds of issues, either with the model or with the tool. Yeah. And the way we are able to do it is exactly pinpoint, okay, this is a particular model which probably has lots of issues with output processing or input processing. So maybe I should choose another model. So that's where we want to help the user identify, kind of do the root cause analysis and make the changes. So I've highlighted some of the key issues. I can stop here for questions or we can continue.
There's one question, of course, it's a little different from what you've been talking about. The question is, how are agents AI better than generative AI?
So internally, agents use generative AI. I mean, finally, it's a large language model which is being used. Just that when we define agents, we say they have large number of capabilities beyond just generating text. For example, they do reasoning and planning. They're able to call tools, external tools, use the context. So I would say the Gen AI models are a subset of agentic AI. That's how we would change. And one of the key capabilities is this part of tool calling.
Sure. And I don't know if you're going to address this later or not. Are the tools that you're talking about, do they only detect these issues or do they also recommend fixes for them?
Our goal is the moment we detect it, we can recommend. We do our recommendations as well. It's a plugin that can be added to the agent ops. So we have this analytics and recommendation. But one of the key areas is always detecting the right issue, right? So that we focus on that quite extensively.
And how do you handle hallucinations in agent ops?
So
if you want to take the questions later, Renuka, if you want to cover something, we can take the question later or up to you.
Yeah, I'll just take this one question on hallucinations. So you're right, hallucinations is an important problem. Models have also evolved. You see less and less hallucination and nowadays compared to maybe a year back or a couple of years back. But what we are looking at is, and for example, here is one way how we could detect hallucinations, right? We exactly know what a tool definition is. And I'm focusing on tool calling hallucination detection because otherwise the area is quite broad. But if I just look at tool calling hallucination detection, the tool has all the definition. We know exactly these are the parameters that the tool would take. This is what the tool does. So when an agent is giving you maybe a parameter name that does not exist in the tool definition, you clearly know it has hallucinated. On the other hand, when the agent, I would say the parameter detection of hallucination is much easier, but the detection of a value. So if I just said manager 3, dry run, I gave this example, okay? Maybe I should have gone to the last. So I just said, get me the issues related to Microsoft VS Code. Here it would be fine. But if the user said limit 25, okay? Limit the number of issues to 25. Ideally, it's a hallucination because the user didn't ask that. And the model has added this information based on its own knowledge. So these are much harder to catch, okay, compared to type mismatch hallucinations, where I exactly know that the model is just supposed to do it, whatever extra it is giving is incorrect. So some hallucinations are difficult to detect, some are a lot more easier. So there is this scope that we also have to identify and trade on. So yeah, so till now I covered 3 of the model-related issues that it cannot detect which tool, it cannot form the input properly, cannot process the output correctly. Some of them are tool-related. So here is one example, right? So this is an example of 2 tools from Kubernetes environment. Now the tool definitions are very similar because they have this huge number of arguments it takes, which is very common in enterprise APIs. You have a tool name and you will have this request body, which will have probably 60 parameters. Okay, and the tool definition here has lots of information about parameters saying this is a namespace, this is a name, field manager, and so on. And in this context, you will see that there is very little difference between these two tool definitions for a model to understand. So one of them says partially updates the config map, other one says creates a config map. Okay, and the rest of everything is the same. So when I say, okay, create a config map using this particular details, I'm very clear from a user perspective, the intent is very clear. They want to create it, but the model thinks it needs to update it, right? So, and the reason here is the tool definition does not really, is not very discriminative for the model to figure out. So here is where we'll have to figure out and say, okay, these particular tools are having a lot of ambiguity. We are seeing a lot of issues related to one tool getting called instead of another tool. And here is where you would want to go and change the tool definitions. So similarly, we have these kind of errors related to lack of input parameters. Here is one example of where the tool is actually not having enough information about, so if I just say request bodies of type object, it would probably not know how to formulate this input. For example, it says milestone in GitHub issue, it passes it as a string. The tool gives an error. Now the model knows exactly what to do, right? Because it got an error. And then it removes that particular information and passes it on and gives the result saying, I couldn't figure out what milestone first meant, but I got some errors, got some of the issues. So these are typical things that you want to do when you're identifying tool issues, right? And I'll just quickly show what we are doing in observability. We are detecting these type of errors and showing it to the user. So here you would exactly know that in your trace, you got so many tool errors, and these were the typical types of errors that you got. So yeah, in the interest of time, I would say I can just quickly talk about what are the key takeaways. The key takeaways is just knowing tool errors is not enough. There are so many reasons for tool errors that we in Agent Ops detect and show it to the user. And at the end of it, the user should be able to say, okay, these could be because of a problem with my model. I change the model, or these are because of my, tool, and then I can change the tool. So that's how I want to overall talk about what we are doing in tool calling.
Okay, thanks, Renuka. There are a lot of questions, so we are already at the top of the hour. Are you okay to speak for an hour, stay on for 5-10 minutes more to answer the questions?
Sure, I can do that.
Okay, all right. So there are a few on LLM which are a little orthogonal, so I'll keep those parked for later. Let me ask one question. What strategies do you recommend for managing context across multiple tool calls so that you can ensure consistency and relevance in the responses from the agents?
So across multiple tool calls, I think most of these agentic frameworks handle this part. Okay, so it's very specific to the frameworks that are underlying there. They have this, all the output of one tool is stored in the context and it's managed. Context to get out of scope. So then there are various, in fact, a lot of research is going on by my colleagues in Yorktown who look at how do you extract only the relevant context and give it for the rest of the tools. So that's a whole field of work that's happening. Yeah.
Another question is this tool definitions that you are talking about, are they similar to a function definition in, say, one of the object-oriented languages?
Exactly. I mean, finally, tools functions are you can
so it's
use
like
them
the meta
interchangeably.
information
Yes.
that you would have,
Yes.
right?
Yes.
Okay, great. Then there are a bunch of questions around LLMs. So please, I don't know, one of you, Asaf or Renuka, you may want to answer this. There are questions around LLMs and the lack of human cognition in LLMs. There's questions around the reliability of the responses, why LLMs and why not use joint embedded predictive architectures. So these are questions related to that. So do you have an opinion one way or the other?
Why LLMs? I mean, okay, in the context of LLMs for agents, I think these are, they've been, I agree they have some limitations, but over time they are doing pretty good job of reasoning, identifying, planning, and so on. That's the reason why we are looking at using them for most of these tasks as well, right? Yeah.
Asaf, do you have an opinion one way or the other?
I can. I'm sorry. I can take the question about human involvement.
Yeah, sure.
So I think human in the loop is key in agentic system in order for the user to trust the agent. Especially in the enterprise system, if the agent fails once, you lose trust in it and you will not use it. Right? It needs to work perfectly 100% of the time. So the open question is how to involve the human. In what phases of the agent? Only at the end and every step of the agent. The second question is, the second question is how to involve the human. Feedback, Q&A, extend, get more information. And the third question, and this is a big challenge, is how often to involve the human. Because if the agent go to the human too much, right, the user too much, then you think, okay, it doesn't know how to do the job, I can do it by myself. But if it's too little, and as a result, it's the agent makes a mistake, you lose the trust in the agent. So this is very delicate, and I think this is a major research area right now in agentic systems. I'm sorry, there are more questions around that than answer. This is
yeah, I think these are questions, I think, not very, it's orthogonal to, I think, today's topic. So probably we'll just park these questions. I'm sure, these are all opinions and, why LLMs, what are the limitations? Can we use alternates to LLMs? These are questions I don't think it was today's agenda. So maybe we'll just park these questions. And let me take this opportunity to thank both you, Asaf and Renuka, for sparing your time here and walking us through the work that you both are doing as part of your research at IBM. So thanks for sharing your insights. And we look forward to many more such very, very interesting talks, especially in cutting edge research. I'm sure a lot of us are now looking forward to the open sourcing of your tool so that we can get hands-on and learn from what you have built. Thank you.
Thank you for having us, and to the audience, feel free to reach out through LinkedIn, continue the discussion. Thank you.
Sure.
Thank you.
Thank you.